Question 10. A car has weight 5,000 newtons, resistance to motion 800 newtons. On flat ground, it can move at a steady speed of 50. When its engine produces maximum power, find the max power output of the engine. We have a car on flat ground. There's a resistance of 800. It's in newtons. So if it's a steady speed, there has to be 800 driving it forward. So the power is that 800 by the steady speed, that tractive effort by V or TV, and the speed is 50. So that's 40, 3 zeros, 40,000. And power is in watts, so that's 40 kilowatts for the power on the flat ground. And then we're asked that there's a hill involved here. Find the car's max speed if the hill has an incline where the sine of A is 1/25. Little diagram. The resistance to motion hasn't changed, still 800. We have this tractive effort driving it forward, that's going to change. We have the normal reaction at the ground. We have the weight here, we're told 5,000 newtons, so it's inbuilt there, it's not kilograms. We don't need the cos part, where the angle is inside here, and it is here, but we do need parallel to the hill, which is going to be 5,000 by the sine of A over 25. 5,000 divided by 5 twice, 1,000 divided by 5, 200 newtons is what's going on in that direction. So that means then that the tractive effort, T, driving it forward, has to be the two opposing forces added together, which is 800 plus 200. So the tractive effort is 1,000 newtons, and we're looking for the power, the car's max speed. So power is equal to TV or FV. So the power that we got up above, 40,000, is equal to the tractive effort driving it forward now times the speed. So you can see V here, 40,000 divided by 1,000 is just 40. That would be in meters per second. In question 11, we have a particle of mass 20 pulled along a rough horizontal plane by a string which is inclined at an angle 30 degrees to the horizontal. So I have my vertical and my horizontal forces in here. So that's what we're asked to find here, the horizontal and vertical components of the tension. And the tension in the string is 80 newtons. So you guys know that the x, we'll call this x and we'll call this y. So x is going to be equal to 80 and it's adjacent, so it's cos 30, and y is going to be equal to 80 by the sine of 30. And you know that 80 by the sine of 30, well, sine 30 is a half, so that's going to give 40 newtons for my y. And just typing this into a calculator, cos is working with root 3 of 2 is obviously a decimal, so that gives around 0.866 times 80 in a calculator. Just round it off here to 69.28 newtons for my x. So that's my horizontal and my vertical. Second question, the normal reaction between the particle and the plane. So I'll just do a bigger diagram down here. Here's my normal reaction. I've got my 80. I've got my 69.28. I've got my 40 mu r going this way. And the mass 20 kilograms, so we have 20 g going down this way. So resolving this, we're going to have vertical or and 40. So r plus 40 is equal to the opposing force going down, 20g, 98, 196, 98 twos, 196. So r is going to be equal to the normal reaction here. It's going to be 156 newtons, which is number 2. Number 3, the acceleration of the particle. Well, we need to involve mu here. So mu r is going to be equal to 1/3 times 156, which is 52 newtons for mu r. And we know that the resolved forces are equal to mass times acceleration. So the resolved forces we have, is that the only one going that way? 52. And the only one going in this direction here is 69.28. That's all that's going on. So 69.28 minus 52 is equal to 20A. So that's going to give me 17.28 over 20 for A, which is equal to 0.864 meters per second squared for acceleration. The total work done in moving the particle through a distance of 0.5 meters. So work is equal to this driving force, this constant tractive effort, 69.28 times the distance. So your TV or your F, your TV 0.5, and dividing 69.28.2, I'm going to get 3,464, and work is in joules.